foundation of advanced math. So in this, again, we'll not be able to finish the entire unit. We'll do part of it, so which is like one little more than 1/3. So we'll start with the same approach. We'll do some sums, and then if that kind of requires us to go back to some of the basic concepts, we'll do that. Okay. So the first lesson is about factoring quadratic and polynomial expressions. Quadratic equation meaning something which has a square, something like this, or polynomial is. So this chapter will deal with quadratic expression and polynomial expressions. So what is polynomial?
It's when there's an equation with multiple degrees.
Multiple degrees, multiple terms actually. So if you are talking about 3x squared or 3x cube or 5x to the power 10, these are expressions, but these are called monomials. Okay. So this has only one term. So this has only one term. Okay. This is why it is called monomial. If you are looking at any expression plus 5 or 3x square plus 7 or 9y square plus 1 or 11z to the power 3 plus x, these are called terms, okay, regardless of the power or degree. Okay. So if an expression has only one term, that is called monomial. This expression has two terms, regardless of the degree. This is a binomial. This is also a binomial. This is also a binomial, because there is one term here, one term here. Okay. Basically, so the way you have to look at it is, look at the number of operands. This is called operands, right? It will be always more than one. So there is no operand, there is monomial. One operand, binomial. If you have two operands, meaning there are three terms, that is called trinomial. And when there are multiple terms, more than one, in general we call that polynomial. Okay. So this is the theory part of it. Now let's try doing some sums here. So what is the first sum that you do, that you see on the first page, bottom of the first page?
8x squared minus 5x minus 22.
So it says if 8x squared minus 5x minus 22 equal to ax plus 11 into bx minus 2, where a and b are constants, these are constants, what is the value of a minus b? What is the value of this? That's what the ask is. So, do you know what this is asking us to do?
Yeah, it's factoring.
We have to factor this. So basically, this polynomial expression.
It's 20 minus 22, by the way.
What is that?
It's minus 22, not 20.
Minus 22. That's it. That's fine. Okay. So it's saying, what is the value of a and b, where a is a constant, b is a constant. So basically, we have to break this polynomial into this form. Let me derive the factor for this polynomial expression. Now the question is, how do we do it? Do you remember?
Yeah, you can go on.
Okay, so here assume this is A, 8 is A, this is B, and this is C. Not in relation to this one, okay? So any polynomial expression, okay? You have to or trinomial expression for that matter. If this coefficient is A, this is B, this is C. Forget about this part, okay? You can always break it into a way that A into C, okay, is equal to sum of this is a into c equal to this b has to be something like a plus b. A plus c. Okay, that's how you have to break it. Meaning the coefficient of x squared multiplied by the constant last term, whatever is the value of that, that has to be this value a into c, whatever it is, that should be broken into two pieces. So okay, let me express this. So let's say this is a, this is b, this is c. Okay, so what is a into c here? 8 into 22
The negative 20.
minus 22.
Yeah.
Okay,
Add
this
the
makes it
negative.
minus 176.
Yeah.
Now this b, whatever is the value of this has to be somehow sum of, this has to be split into two factors. Okay, and sum of that has to be equal to this. Now here let's look at what are the factors for this one, 176. You can write this as 2 into 88.
That won't equal to negative 5.
Yeah.
Yeah.
Or you can say 4 into 44. Yeah. So we have to find out the two factors. When you add them together, it has to come to minus 5. So this is minus 176. So you can say minus 288. Okay. So let's look at what are the numbers first. If I say 6 to the 12, 5, 6. No, this will not. So 6 will not work. I can make it 8 into 22. This is not anywhere close to minus 5. Make it 16 into 11. Yeah. So now we have to get to minus 5. That means the minus is more. This is minus. Oh, this is okay. So if I say minus 16 plus 11.
Then it equals to negative 5.
Okay.
That will work.
So now that means I can break this equation in a way minus 5x, I will say minus 16x plus 11x minus 22. Okay. So basically again, any quadratic equation or expression that you come across, you have to look at this coefficient and this coefficient, multiply them, and then try deriving the factors, which is sum of this. That will be a simple formula or simple approach that you have to follow everywhere for factorizing it. Okay, and that works. I mean, if you look at what I have noted down in this one, right? There are two methods, but actually when I analyze it further, I realize that you don't have to remember two things. Just do one way. Multiply this coefficient with this one, find out what is the value, and see how you can break that into two factors as a sum of this. Okay. Now here, now it is easy, right? 8x is, take these two as combination, right? 8x, so this becomes x minus 2 plus here take 11 is common, x minus 2. So this can be broken to 8x plus 11 into x minus 2. This is the factorization. Now look at this equation now. So bx is x, meaning b equals to 1. Yeah? And here 8x plus 11. 8x is equal to 8. Yeah?
Yeah.
What was the question? Find out what is a minus b. Yeah?
Yeah.
Done? 7?
Yeah.
Clear?
Yeah.
So, here, now let's look at this. This as a conclusion, right? If you have to factorize any quadratic expression like this, okay? Look at this and this. First thing you should do is multiply these two and find out what the value is. Okay? Now, whatever is the value of this A into C, figure out how you want to break B as a factor of this, whatever is AC, right? Let's say the factor is A dash C dash, okay? So, you have to find out the value of B. Basically, you have to find out the factors in a way that this plus this equals B. That's all. So first multiply these two coefficients, get the value, and then try factoring that in a way that's the sum of this. Sum of that is equal to B. Okay? And this is the universal approach that you can apply for factorizing any quadratic expression. And then apart from that, what you must be knowing is what is this called? There's a term for this one. These are called elements of quadratic expression. A plus B whole square equals to A plus 2AB plus B square. A minus B whole square equals A square minus 2AB plus B square. And A square minus B square equals A plus B into A minus B. These three equations that you have to, that you would be remembering by now. Whenever you have been asked to do any factorization, first thing you will try doing is see if this is matching with any of this. Okay, let's say, let me give you an example. 4x square plus 8x plus 16. Is it matching with any of these? So if I see all plus, only possibility that this guy has is it could be a form of A plus B whole square. I can always do that same approach. Multiply this with this and then find the factor is this. That is one way. Second is, I have a simpler solution. Let me see if I can write this in the form of A plus B whole square. So 4x square, 4 is also a square. So I can write this as 2x square. Yeah? Plus I can write 8 as 2 into 2x into 2. 2. Okay, 2 into 2 into 2. Okay. Plus 16, I can write this as 4 square. So this is A, this is B. Right? So this is, but here it is 2. So basically I wrote the wrong equation. It could have been 16 actually. That would have given you A plus B whole square. Now if this is not matching with this, what you will do is, you will simply go with the old approach. Multiply this with this. This is, if I said 8x, right? Multiply this with this. 16 4 just 64. Okay? I have to break it down in a way that the sum is this. So 64, 2 into 32, 4 into 16, 8 into 8. Yeah?
Yeah.
That's it. What happened?
Yeah.
This is no, don't use calculator. I don't encourage using calculator. Okay. So this is not coming as a clear fraction actually. So then we'll figure out what to do with this one. This kind of this thing. Okay. You can always say, okay, what is missing? Okay. If I would have added 2x, so this is like, if this was 16x, then that would have been a perfect square like this. So this is this minus 8x. So this becomes 2x plus 4 whole square minus 8x. You can write it like this also. Yeah. So anyways, this is not factorization, but I'm just saying the question was not right. That's why we are not able to do it. Yeah.
Yeah.
Now let's look at the next question. Page 2 of this one. Okay. Which of the following is equivalent to 4x square plus 28x plus 49? Quickly, always when you look at this, A plus B whole square kind of a thing, it could be. So this is 2x square plus, if you take 2x out, into 2, and then what is remaining is 7.
Yeah.
Yeah. plus 49 is 7 squared. This looks like a perfect this thing. A square plus 2ab plus b square.
Yeah.
Yeah?
Yeah.
So you don't have to do any calculation, you don't have to do multiplication and everything, right? So this is straight 2x plus 7 whole square. Look at the answers now.
2x plus 7.
Which one is the answer?
D.
D. Yeah. So this kind of thing, right? You will, when you look at the question, just read it once and it's very clear saying, okay, which one this looks like. First thing that should always strike you is a plus b whole square or a minus b whole square or a square minus b square. Whichever format this looks closer to, you will not compare this with a minus b whole square. By no means it can be like that, right? So it's a plus b whole square. It's a possibility is a plus b whole square. Now see whether this is a square, this is b square, and this is 2ab. As soon as you draw the correlation, you're done. Let's look at the next one. And I will not talk. You tell me what the answer is.
It's A.
Okay. Okay, very simple, right? Which of the following is equivalent to 2x to the power 5? 2x to the power 5 minus 8x. Okay. You said A. Okay. So what did you do?
I factored out 2x because that's like,
That's common, right?
yeah.
So this is x4 minus 4.
And then you just factor x4 minus.
Now here this what you did was x4 can be written as x square of x squared. Yeah. Minus 4 can be written as 2 square of 2. So that's why this is a square minus b square. So a square minus b square is a plus b into a minus b. That's how you got the answer is. So 2x multiplied by x square minus 2 into x square plus 2. That's what you did?
Yeah.
That's what the first answer is. Okay. Now, so here, by looking at this one, first thing you wanted to do was take the common thing out, right? That becomes your first factor. And then see if there's a possibility of breaking this further. That's what you did. Okay. Now let's go to the chapter 2 of this unit, which is about radicals and rational exponents. Radicals and rational exponents. Now, let's look at the sums and then we will see if we need to go back to the concepts. Yeah?
Yeah.
First question is, which of the following is equivalent to 2x cube dot 3x5? 2x cube into 3x5. When you multiply or add, you never add apple to banana, banana to apple. You add apple to apple, banana to banana, right?
Yeah.
Or you compare, that's what people say, right? It's like comparing apple to bananas, apple to oranges, right? So, you always go with this. So what is the answer here first? You tell me.
It's 6x to the power of 8.
6x to the power of 8. So when we talked about apple to oranges, we picked up the apples and oranges separately. So this was the apple, this is the apple, constant, 2 into 3, you multiply them, that became 6. And then x to the power 3 multiplied by x to the power 5. And here we know exponents, how the exponents get added, right?
Yeah.
Yeah. So this becomes x to the power 3 plus 5. 6x to the power 8. Okay. Now next question. You tell me what is the deal all about.
So I just made it into a b to the power b over 2 equals 5 to the power of 2 because that's like equivalent.
No, what is the question first?
It's a to the power of b over 2 equals 25.
8, if a equal to 8, if a to the power b by 2 equals 25, for positive integers a and b, what is the possible value of b? Okay. Okay, yeah. Now you can tell me.
And then I just got that b equals 4 because if a equals 5.
Uh-huh. Yeah. So you replaced a with 5 to the power b by 2 equals to 5 to the power 2. So you can say b to the power 2 equals to
2.
2. Yeah. So that makes it clear.
Yeah.
Now, so here in exponents, we are so far we are comfortable. Let's look at the next question. If n to the power 1 by 3, come on, this matter is right. N to the power 1 by 3 equals x, where n is greater than 0. What is n in terms of x? Okay. Yeah. What is n in terms of x? Yeah, that's a good question. I mean, it's an easy one, not a difficult one. You want me to go ahead?
Yeah.
Okay. See, before we do this, there is one thing that we have to remember. X to power 2 means x into x. Sorry, x into x. X to the power 1 by 2 means
X to the power.
1 by x to the power 2. No, no,
That's not.
that's
it
not
would
correct.
equal-
That's minus. Okay, yeah, this
That would
is
be
okay.
1 over 2 would equal. It would
Uh-huh.
just be the
So
square
this
root.
x power this means square root of x. Yeah. Inverse of a square actually.
Yeah.
Okay. Now put x to the power 1 by 3 means cube root of x. Hmm? Same way here n to the power 1 by 3 meaning cube root of n. This is how you write it. This is called radical. Yeah, this is a radical form, right? Equals to x. So cube root of n equals x. So that's the question was, what is n in terms of x? So cube root of n is equals to x. So n equal to
X to the power of 3.
yes.
But none of the answer choices.
So what is n? Okay, let's go back to the basics a little bit. So with the exponents, this is the thing that we know. X square equals to x into x. X to the power minus 2 means 1 by x into x. Clear? X to the power 1 by 2 is square root of x. Yeah?
Yeah.
Something x to the power n into x to the power m equals to x to the power m plus n. Now, here the question is n to the power 1 by 3 equal to x. Okay? So, that means n to the power cube root of n equals to x. Meaning, if you do cube of this and cube of this, that will be the same, right?
Yeah.
So that makes it n equals to x to the power 3. Now, the question is, what is n in terms of x? Okay. 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 Yeah. So this is n equal to x to power 3, right? So I can also write this as 1 by x to power minus 3. Can I?
Yeah.
See if there is anything that is,
Yeah. There is.
yeah? And you can say 1 by minus 3 like this, right? Or sorry, you can write this as n is x. So n to power, okay. Are we reading the question right? N to the power 1 by 3 is this. And what is n in terms of x? So first one is ruled out, right? There is no minus. So all the ones with minus, that should be ruled out. First and third should be gone, right?
Yeah.
Now, n equal to x cube. See, this is how it has to be. N equal to x cube. Okay, so do one thing. When you do this exercise, right, in Khan Academy, just try looking at the answer, explanation for this one. There seems something wrong with the question actually.
Okay.
So just check it once. So first, A and C, in all this kind of scenario, right, you have to always look at how do you eliminate the wrong answers. So there is no minus, right? So that minus has to be taken out. Now the only possibility is B or D, and we'll have to look at why this is wrong. It should be actually x cube, not 1 by x cube. The answer should be B. Okay, now let's go to the next one. So, but in a way, while doing this, we kind of did a recap of how the exponent, how do we deal with the exponents, okay?
Yeah.
Now, let's go to the next one. Which of the following is equivalent to the expression above? Expression above. Which of the following is equivalent to the expression above? Okay. So let's see the expression. It says 8x to the power 8 y to the power 6 divided by square root of 4x squared y6. So whenever you see that square root or cube root, right? When you see a 3 here, that is a cube root. If you don't see anything, that is a square root. That's how the rationals are to be interpreted. So do you know what the answer is?
No.
No?
But yeah, no, I don't.
Okay, now before we go there, right? Very simple. If you have, let's say, x squared into y squared, and you have to do a square root. Okay? A square root means something to the power 1 by 2. A square means to the power 2, square root means to the power 1 by 2. So, or cube root means to the power something to, if you have y6 cube root, that means you can also write this as x cube into y6 to the power 1 by 3. This is how you can write it. Okay? If it is this, you can write this as x square into y square to the power 1 by 2. So square is power 2, square root is power 1 by 2. Cube is power 3, cube root is power 1 by 3. Okay? Now apply this formula here. So this is cube root. That means I can write this as 8x to the power 8 multiplied by y to the power 6 to the power 1 by 3. Here this is 4x squared y6 to the power 1 by 2. Now this becomes much easier. So another thing that you would have already known by now is if you have a to power n to the power m. In this case, this gets multiplied. This becomes n into n. If you have a to power n into a to power n, this becomes a to power n plus n. This difference is clear, right?
Yeah.
So here, now this is much easier. So this becomes 8x power 8. So this 8 to the power 1 by 3, or this like this, into y to the power 6 into or by 3 basically. Here also 4 to the power half into x square by 2 into y to the power 6 by 2. So this is 1 cube of 8, 2 to the 8. So 2 into 8 by 3, 8 to the power x to the power 8 by 3. Okay? Or whatever. Into y to the power 6 by 3, so y square. Here you have 4 square root 2 into x to the power 2 by 2 is 1. Into y to the power 6
3.
by 2, 3, y cube. So this is 2x to the power 8 by 3 into y square by 2 into x into y cube. So this becomes y. This is 8 by 3. So out of 8 by 3, if you do 1, so this becomes 5 by 3. And this 2 gets out. So x to the power 5 by 3 by y. See if you see anything like this. Huh? Did we miss something? Okay. X to the power 8 by 3 minus 1. By 3. It should be x to the power 5 by 3.
Oh, it's B.
It's
Because
x to the power, right. So x into
X, so it would be
x to the
X.
power 2 by 3.
Yeah.
Yeah. 5 by 3 is x. 1 plus 2 by 3 is 5 by 3, right?
Yeah.
So this is B. Yeah. So this chapter that is about radicals and rational exponents. See, there are 2-3 things that we have to remember. If you multiply something with the same constant with some other factor, the power gets added. If you divide, it gets subtracted. Meaning e to the power m into e to the power n becomes e to the power m plus n. If you divide e to the power m by e to the power n, it becomes e to the power m minus n. Yeah?
Yeah.
If you do e to the power m to the power n, this becomes e to the power m into n. Okay? E to the power 2 can be written as 1 by e to the power minus 2. Okay? So these are some of the basic thumb rules that we don't have to memorize. This you will know by practice.
Yeah.
So now we go to the next chapter, which is operation with polynomials. Again, when we say polynomials, we are talking about an expression with more than one term. Okay. Now let's look at some of the questions. Which of the following is the sum of x square plus 5 and 2x square plus 4x? Yeah?
Yeah.
You always add apples to apples. You will add apples to apples. So it becomes x square here, 2x square here. That is 3x square plus 4x plus 5. Which one is the answer?
A.
That you know. Now let's look at the next one. And you tell me what is that? 9. Okay. So let me.
It would be, the equation would become 3x squared plus x minus 1.
Okay, so it says, just read it for me.
9x squared plus 5x minus 1.
Uh-huh.
And then that's in parentheses. And then minus parentheses 6x squared minus 4x.
Okay.
Yeah, equals ax squared plus bx plus c.
So what we are trying, this is called left hand side, this is called right hand side of the equation. Alright?
Yeah.
So let's resolve what we have on the left hand side. Add apples to apples. What did you say? What the value will be?
Squared
3x squared
plus x
plus
x
yx.
1x.
Now,
Yeah. Oh, sorry. Plus 9x.
yeah,
Plus 9x minus 1.
okay. And on the right hand side you have ax squared plus bx plus c.
Yeah.
Now you have to find out value
A b, which is
where
just
a,
9.
b, c are constant. What is the value of b? What is the value of b?
9.
9. Right?
Yeah.
So these are simplest of the maths, but needs care and practice. Okay.
Yeah.
So I would be surprised if anybody says that a student like you would not know it, but it's just about practice. Okay.
Yeah.
So what we are doing is only practice. Now look at the next question. Which of the following is equivalent to x plus 3 into 2x minus 5? X plus 3 into 2x minus 5. You tell me, how will you do it?
You would just multiply x
Uh-huh.
by 2x, then
Uh-huh.
you just FOIL it. So x times 2x, then x minus, and then x times negative 5,
Mhm.
and 3 times 2x,
Uh-huh.
and then 3 times negative 5.
Uh-huh.
And then after foiling it, you would just get 2x squared minus 5x
Uh-huh.
plus 6x minus 15.
Uh-huh.
And then minus 5 plus 6 is just 1x.
Hmm.
So 2x
So
plus 1x minus 15. So that's just C.
Okay. Now I'll tell you one interesting thing. When you're dealing with this kind of questions, right? If you want to save time, you can use a technique called elimination technique.
Yeah.
So here, if you look at x plus 3 to x minus 5. So the x square one, right? It will be 2x squared. Anything which is not 2x squared, you can simply eliminate that. So a is gone. Now look at the c part of it. C part of it can be 3 into minus 5, minus 15. Whichever is not minus 15, you can eliminate that.
Yeah.
So D is also gone. Now you're left with B and C. And I have not spent much time so far, okay? Now you'll see that the x part, right? X into 5, minus 5, that becomes minus 5x. And then this 3 into 2x becomes 6x. So plus 6x minus 5x. That will be 1x. So out of the remaining two B and C, the only one that has this thing is this. You don't have to do the whole calculation actually. You can just keep on eliminating the ones that you don't need. Okay? Try using that. You will see that you're able to save some time actually. Yeah? So with the multiple choice question, it's always advised to use elimination techniques wherever you can.
Yeah.
I mean something that you can make out just by looking at the question actually. Yeah?
Yeah.
Okay, so that concludes our chapter 3, lesson 3 of this unit. Next one is operations with rational expressions. So rational expressions, meaning expressions, we talked about expressions like polynomial expression, monomial expression. We talked about binomial expression. We talked about as polynomial expression, right? It says operations rational expressions, meaning these expressions which has rational numbers, something like this, 3 by 5x, anything like that, wherever you're dealing with rational numbers. So let's look at odd expressions like this, 2 by x plus 1 minus, this is the sum, right? That's what we're trying to do.
Yeah.
So it says let's look at some of the sums. Because see, there's nothing new from a concept point of view. It's just about how do you play with this.
Yeah.
I call it tic-tac-toe. So what is the question? Which of the following is equivalent to this? 2 by x plus 1 into x plus 1 by x plus 2. What is the answer?
Huh?
What is the answer for this one? The first question, next page.
Oh, next. I thought we were doing this one. There's another sum. Or do we not do that?
Did we have anything here?
But that is just 2 over x plus
2 over x plus 1, right?
plus 2. 2 over x plus 2.
Yeah, 2 over x plus 2. Yeah, correct. So here, again, here also you would have seen the elimination technique, right?
Yeah.
Because these two are gone. Anything which has x plus 1 or okay, anyway, this is a straight answer anyways. 2 by x plus 2, so you don't have to do anything.
Yeah.
So elimination technique is not always useful actually.
Yeah.
So here you did doing the calculation was faster. That's why you did the calculation and got the answer.
Yeah.
Elimination technique you will use when you can get the answer without doing the calculation actually.
Yeah.
The whole calculation. Now next one. X square plus 5x plus 6 by x plus 4 into x square minus plus 4x by x plus 3. This is interesting.
I'm still working on it.
Okay.
Yeah, I got D.
D. How? You would have taken x common here. That makes it x plus 4, right?
Yeah.
So this became x. This was gone. So this became x square plus 5x plus 6 into x divided by x plus 3. Your answer is x square plus 2x.
Yes.
Okay. So this one is what?
That one factored is x plus 3 times x plus 2.
X plus 2. Yeah. So here also see. Look at the same approach, right? You would have done the same approach, right? 6 into 1, A into C. Now 6 and 1 is 6. You have to break this into a way that becomes 5. So you would have done 6 minus 1. Right?
Yeah.
So this would become x square plus 6x minus x plus 6.
Yeah.
Okay. This multiplied by x divided by x plus 3. So this is x. So here you take x common, so it becomes x minus 6 minus, you'll take 1 common, this becomes x minus 6 divide, and then this is outside we have x plus 3.
Yeah.
So how come it's D?
Because so x the first one, x to the power of 2 plus 5x plus 6, right? You would, that is x plus 3. Huh? Wait, what? Huh? Wait, where did you get that from?
Did I?
X minus 1 plus.
Huh?
No. It would become 3 plus 3 and 2.
3 and 2. Okay. Got it. Yeah, 3 and 2.
And yeah, I think you wrote
Okay. Okay, yeah. If I go 6 and minus 1, that becomes minus 6, right? So that will not be the case.
That's
So I chose the wrong option, right?
Yeah.
So here it has to be 3. So 6 into 1 is 6. It has to be 3 into 2.
Yeah.
That's how 3 plus 2, 5x. So yeah. So this will become x plus 3 into x plus 2 multiplied by x divided by whatever is the remainder.
Wait,
Yeah.
why would you multiply x? Oh, okay, yeah.
Because that's what was left
Yeah.
from this
After
one, right?
cancelling everything out.
Yeah. No, not cancelling everything out. This part, it had x square plus 4x, right? So I took x common. That's how it become x plus 4.
Yeah.
And then this one, that one got cancelled, right?
And then x plus 3 and the 2x plus 3s would get cancelled out too.
Right. So these two get cancelled. So that is how you're left with x into x plus 2. So that becomes x squared plus 2x,
Yeah.
which is D. Yeah.
Yeah.
So this, see again, why I chose this one and I went wrong, because I made this in a hurry, right? I did not look at this 5 being 6 minus 1 as the right option or not, right? But anyways, thankfully, this was not one of the options. That's why I kind of got stuck. And it made me, review it. Otherwise, I would have just chosen that option and gone ahead.
Yeah.
Okay, now you look at the next question. So, this is a classic example of adding fractions with polynomials. You're adding. So far we were doing multiplication, factorization, right? This one is addition. 4 by x plus 1. You do it. I'm just noting it down.
Okay.
2x minus 3.
Yeah. Done.
Done? So then what did you do?
I got D. Oh wait, what?
It's D.
Yeah.
And okay, so let me quickly do it without trying to explain this, okay, so that we can verify this. So this becomes x plus 1 into 2x minus 3. So here x minus 1, so this is 4 into 2x minus 3 minus 3 into x plus 1.
Yeah.
So this becomes 4 into 2x, 8x minus 12 minus 3x minus 3 by x plus 1 into 2x minus 3.
Yeah.
So 8x minus 3x equals 5x minus
15.
15.
And then 2x squared minus
1,
that's
2x minus 3.
and that would equal 2x squared
So
minus
5 I
x
will
minus
take common, so becomes x minus 53, right?
Yeah. And then the x plus 1 times 2x minus 3 would become
Huh?
2x squared minus x minus 3.
Did I miss something?
Huh? You just have to
5
multiply x plus 1 and
Oh, this one. Okay,
yeah.
okay, got it. No, that's what I was thinking. I mean, the denominator I have not touched yet, right?
Yeah,
So
that would
that's
be
what will be. So see, my numerator. See here, I can still be lazy.
Yeah.
I know that 5x minus 3, and here there is nothing common.
Yeah.
There is nothing that is going to get cancelled out. Now I know that my numerator is 5 into x minus 3. If I look at all the 4 options, the only option that has this value is this.
Right.
Done.
Done.
Right?
Yeah.
So these are small opportunities that we have to use for saving time. Yeah?
Yeah.
Now let's look at the last sum here. Which is the following equivalent to x square plus 5x plus 2 divided by x plus 5. So if you look at this guy, this is 2. Can I break this into 2 parts? Okay. So if I have to make this as a plus b square. So here also you'll use the same elimination technique. It's b. You're saying it's b.
Yeah. So you can factor x squared plus 5x plus 2, right? So you would just look at x squared plus 5x and ignore the plus 2. And from that you would get x times x plus 5. And then plus 2 over x plus 5. And you can just cancel out x plus 5.
Right. X plus 5 plus 2 by x plus 5. Right?
Yeah, and then cancel out the x
So
plus 5.
you will take this as one example, take this as second one, right?
Yeah.
X into x plus 5 by x plus. So this becomes x into x plus 5 divided by x plus 5
And that just equals x.
plus 2 by x plus 5.
No.
Why?
No. Yeah.
Yeah,
Yeah.
that's how it has to be.
Yes.
That's why it's not going to be b.
Oh. Okay.
So
Then it would be c.
these two are gone. X plus 2, x plus 5. Yeah?
Yeah.
So don't trust yourself. Don't trust me either. What happens is, this is part of the review actually.
Yeah.
So anyone can go wrong. So whenever you're doing any calculation, it's once you're done with that sum, just spend 10 seconds to just glance through it. Did I do everything?
Yeah.
You may or may not be able to get to that point. Okay, the whatever we got just now, right?
Yeah.
I was not trusting you. So you may be able to catch it. You may not be able to catch it, but it's always a good idea to review. Okay. Now last chapter in this one. For today's class, right? Non-linear function or composite functions. Composite functions, if you want to know about, this is function of function. If I say y is a function of x in a way that y equals to x squared plus 3, yeah?
Yeah.
You can also say g is a function of y, and we know that g is a function of y, meaning y is already a function of x. This is what makes it function of function.
Yeah.
Parent-child relationship. Look at this first sum. Px equal to 2 by x. So 2 by x. Function p is defined above. What is the value of p2 plus p5? P2 will be 1
I got a 7 over 5.
plus 2 by 5, yeah? Yeah, 7 by 5. Next question is, if fx equals to 3x plus 5 and gx equals to x square minus 4, what is the value of g of f1? What is the value? What is the answer?
Huh? That is, wait a second. 60. 60.
Record is there, tum?
60.
Okay, so you'll first get f1. So you'll put 1 in place of x in this formula, and then whatever value comes, that you'll put in this formula. That's what it will be.
Yeah.
I'm not checking that right now. Let's look at the next one. The table above shows the value of function h at certain value of x. What is the value of h of 3? Okay. Do you know what it will be?
Huh? Yeah,
Next.
7.
7. How did you do it?
So I just plugged in, so 3. So find the x value for 3, which is negative 3 for hx. And then I would just went back to the negative 3.
Yeah. This is function of function, right?
Yeah.
So you have the value for different numbers. You plug the first value, so this function goes off and then becomes a number, and then for that particular number you solve the result. Yeah. This is how it is. Next one is function of x, fx equals x square minus 2x minus 5. Which of the following is equivalent to f x plus 3?
Is it A?
Why would you guess?
No.
It's very simple, okay? Here, function of x equals to x square plus minus 2x plus 5. Function of x plus 3. So you'll replace x with this. So this becomes, instead of x, you will say x plus 3 square. Minus 2, instead of x, you will say x plus 3. Minus 5. Now you find it out. X square plus 6x plus 9 minus 2x minus 6 minus 5. So this becomes x square 6x minus 2x plus 4x 9 minus 6 minus 5 minus 2. B.
Yeah.
Okay. So this function thing is very easy. Ideally speaking, what you have to do is just substitute this value,
Yeah.
whatever you are trying to find the function for, with the variable. Just replace it with that, it should be fine.